Well, welcome to our panel, and we're really blessed to have a very distinguished vendor panel, or panel of representatives of vendors, I should say. And in keeping with the theme of the conference, which is sort of organically developed, we're going to talk about HPC and American competitiveness, and within the context largely of manufacturing. So we've talked about different ways that manufacturers have been helped by HPC. We've had various views on whether it really is critical to American competitiveness and how it fits with the future of American productivity and America's industrial base. So generally we're going to keep with that theme in this discussion and let it go in various different directions. The way this will work is it's a very informal panel. There's no slides, there's no presentations per se, it's just a conversation. And so my job is simply to facilitate that conversation and get it started and rolling. So variously in the course of the presentation.
And it was so informal that I'm late, sorry.
Well, you're here now. It's not like I've stopped talking. Variously in the presentations, we've heard different things about various levels of success in helping manufacturers large and small, whether you call it the missing middle or to use Dr. Fernandez's phrase, I think it's the next 5,000, whatever you call it, the expansion of HPC downward through the middle. We've heard various comments about how different organizations like the folks at Oak Ridge and some folks in the UK have been helping manufacturers. And we want to talk about, I'd like to get at some opinions about how to build a model in the United States that helps facilitate that here. And one of the comments that was made in the very first presentation by John West was, for those of us in the room, we think that HPC is like the sun. It's there, it's obvious, it's the center of all goodness and provides, you know, the glow that helps us all live. So I wanted to start out by discussing whether or not that is a justified view in competitiveness, and I'll ask that question in a minute. First thing I'd like to do is to ask each of our panelists, these mics should all be live. Can you just tap those and see if that's true? Very good. Also a very rhythmic group. So first thing I'd like to do is just go down and get a very brief introduction of who our panelists are and what they do. And I'd like to ask each of you to just give us a very brief look at that.
So I'm Marc Fernandez. I'm with Dell. I've been with Dell coming up on 3 years. I was brought on board to address, as has been discussed, the next 5,000 market. We are not focused on supercomputers or quantum computers or the top 500. We work there cooperatively as we can, but we're really focused on that next 5,000, that missing middle, that small to medium manufacturer, educational space, or elsewhere.
So I'm Bill Feiereisen, and I've been with Intel for about 1.5 years now. Before that, I was over at Lockheed Martin as the Director of High Performance Computing there, but Stephen Wheat, over the last couple of years, enticed me to come to Intel to work on mid-range missing middle computing, and it's been a great deal of fun.
Marc Hamilton with HP. I run the High Performance Computing Group for the Americas. I was actually brought in for the opposite reason. I think HP does fairly well in the bottom 400, and I was brought in specifically to focus on and grow the business in the top 100. But at the same time, I was told that don't lose that base that we have. So we certainly focus, across the board on, everything from the top 5 to the next 5,000.
So Matt Jacobs, Senior Vice President of Corporate Development with Penguin Computing. So at Penguin, I head up the strategic initiatives of the company in those directions. Actually started the HPC practice at Penguin Computing a little over 12 years ago, so been there quite some time. We're probably the small upstart here, I guess, at this table, but focused on really delivering end-to-end comprehensive solutions for the customer base. And that starts from the workstation all the way up to the cloud. And I think it'll give us a unique perspective today in this discussion in terms of how we actually address each of the different segments of our customers from large to small.
Steve Linus, I'm the Vice President of HPC Solutions Engineering at Appro. Interesting that you say that you're the upstart, but so one of the other small, completely HPC-focused companies. I've been with Appro for almost 5 years now. Came out of Silverstorm before that, and also with NetEffect. So I've been doing HPC for I guess about 10 years. And so I have responsibility for all of the pre-sales engineering, the professional services, and post-sales support.
Hi, my name's Eng Lim from SGI. I've been with the company 23 years. In the manufacturing space, we sell to Ford Motor Companies, the Ford Motor Company, to Mazda and BMWs, such like, and also to aerospace, Boeing. I think in terms of the smaller manufacturers, we can also focus on the suppliers to these car companies, because many of these parts, smaller parts, the car companies don't build. They get them from these smaller manufacturers. How to get those supercomputing capabilities that these big car companies use downstream to these suppliers. So this could be an interesting discussion there.
And now I have two mics. My name is Geoffrey Noer. I'm Senior Director of Product Marketing at Panasas. Maybe we're the upstart storage company on the panel, but
You can all be upstarts, okay?
but we're of course focused on our parallel file system based appliance. We've been around now for more than 10 years, and what's nice about the Panasas solution is that it starts out very strong in the high tens of terabytes into the hundreds of terabytes and scales all the way into the petabyte class systems. So particularly in the manufacturing space where ease of use and reliability and performance are all valued, having a commercial quality solution is something where we've always really shined. And also that also comes to bear when it comes to performance, because if you have a decent-sized Linux cluster, but you don't need all that much capacity to start with, we can deliver that performance with far fewer spindles. And we've worked a lot with ANSYS and CD Adapco and all the other ISVs in the space, as I'm sure have a lot of other people on the panel.
Okay, thank you. Other than that, we don't have any expertise or experience here on the panel, so pretty good group. Thank you very much. First general question. Some arguments or some things were said about small, mid-sized manufacturers feeling like maybe they're not convinced, or they're not really aware of the importance of HPC in their lives, that there's straightforward ways for them to do it. The example of the windshield wiper manufacturer who takes it to New Zealand and tests it. Is there any reason to doubt, or is there any case to be made as to whether or not HPC really is critical to American competitive position in manufacturing? Why is it that the use of HPC can change America in the sense of creating jobs, of generating differentiation, higher quality, innovation? Does anybody want to make the case that it really isn't, or make a case that it really is? Mark?
It's absolutely critical to America and society as a whole, in fact, that we advance HPC and that we address the small to medium manufacturers. They are bumping up against walls, such as we've bumped up against walls. We've bumped up against power walls, memory walls, other things. They're bumping up against labor cost walls, supply chain issues, and other types of walls, and HPC can help in that. My main point when I discuss with small to medium manufacturers is I don't use any of the lingo that's been used today. We have to advance the small to medium manufacturers by talking about their problems and advancing solutions toward their problems. A couple of people have mentioned that today in terms of not necessarily time to solution, but quality, get their attention by addressing the quality issue, which can apply to anything besides HPC as well. So we have to couch our position in business terms, and that's a bit more difficult to do. I'll let others just
Critical?
Well, I obviously think it's absolutely critical, but then again, I think like a lot of people in this room, I've grown up in the, let's say, the traditional HPC field, in that HPC means modeling and simulation. And I think I'm taking up on some of the words that Marc just said, but I think that the needs of manufacturers are varied, and they are much wider than just modeling and simulation. They encompass the entire stream of types of technical computing that are probably broader than CAD/CAM, they're broader than data analysis, they're broader than data handling, and that those of us who've grown up in the center of the big machines really concentrate particularly upon modeling and simulation. And in some respects, we are trying to impose our view of what HPC is on what manufacturers really need. And so, you know, I resonate entirely with what Marc just said, in that we have to listen to what manufacturers need and concentrate on their big, broad workflow, of which modeling and simulation is a piece.
Marc, beyond CAD/CAM, the whole business model, we have to create a new language? Yes, no?
Well, I think it's important to remember that a small medium manufacturer probably has never been inside the supercomputer center, and probably knows how to spell HPC, and maybe doesn't know how to spell GPU, and so I think certainly it's time to market and product quality is what they have to gain, but it's going to be a very different approach than traditional HPC data center. I like to talk about the 3 C's, right? About cloud, client, and consumerization. Right? Certainly, to go in and ask a small or medium business that's selling as a few $1 million a year in revenue to spend $100,000 to buy a half-rack cluster, and then spend $150,000 to hire someone to administer that, is not feasible, right? So providing cloud access is going to be important. The client part really spans everything from the programming model for developers to just how do you sit down and use that. If you look at things that NVIDIA is doing with their Optimus workstation, putting a Fermi GPU in with a Quadro GPU for the rendering in a workstation, so that you can do the rendering and then that back-end compute on the same workstation and have that instant turnaround. So I think that the power that delivers is what was in the supercomputer center a few years ago. So that whole client side changes. And again, around consumerization, well, typically people think of consumerization for the end client device. In effect, what most companies are buying for HPC is maybe not a consumer-oriented server, but very much, I would say, a commodity server, right? It's something that companies have to be able to ship thousands or tens of thousands of and service them at that scale as well. So I think I like to talk about it in terms of the 3 C's again: cloud, client, and consumerization.
We'll come back to that. Matt?
Sure. Thanks. I couldn't agree more. I think there's a big aspect of what we're trying to do in terms of translation. I think also making it viable and meaningful to these companies to be able to actually invest in it. It is a mindset change. It's funny, I was reading a Wall Street Journal article, I guess it was this week. Many of you probably also read it around the Chinese investment in HPC and their approach to it. And it's interesting, they're funding at a local level rather than a national level. So this particular article revolved around the Nebula supercomputer that they just stood up. And it was talking about how local municipalities actually control the sort of work that's being done on these supercomputers. And I found that interesting because they're focused on manufacturing problems that are relevant to their local economy. And so I think they're really taking a ground-up approach. Yeah, but if you look at the two nations, we have 74, or they have 74 supercomputers in the top 500 list. We have 265, something like that. So So I think we have a good program here. I don't think we're doing anything wrong. I think we've done everything right. I think what we need to do is build on that. And I think translating what we've done as a national investment to make it viable for applied sciences in the industry is going to be critical for us moving forward. And I think that's where you look at things like cloud. Of course, we at Penguin believe heavily in that. We've invested heavily in that. Making it relevant for these people in terms of ISV licenses. How do we lower the cost of entry? How do we lower the barrier to entry? And not to say that the licenses are too expensive, but maybe there are different models that we can approach that are more time-based and more variable than less fixed cost. So I think we're doing a lot the right way here in this country, and I think that there are elements that we can improve on to increase adoption.
Steve.
So I think a lot of what I've seen when I go out to something like an ANSYS conference, right, is you see end users who are now thinking more about HPC, but even when you start talking to them and start realizing that they're going to go up to 8, 16, 32 processes, that now you can, more often than not, stick into a single node. HPC to them can often be 2 servers connected to an Ethernet switch. Right? But for them, it's become difficult because of the programming paradigm and the ability to go in and take codes that had been running single thread and being able to make them run efficiently on multiple cores simultaneously, particularly if they're doing their own programming. I mean, a lot of the commercial companies that had been doing like the finite element analysis with small core counts are now making it easier for their customers to use the off-the-shelf software, right, which is going to start spreading more adoption, right? It's like the ANSYS is, again, another good example, where they have changed their whole licensing scheme to really promote multi-core and multi-system simulations.
Before doing computer science, my first degree was actually in mechanical engineering. And in designing of these products, right, there is the highest level where you conceptualize the product, then you refine that product, and you try to mass produce it. I think the US has a very strong edge in the conceptualization stage. Yeah, the U.S. is very, very strong creativity good creativity in conceptualizing new products. I think where we need to spend more energy on also is in the product refinement area, where actually Europe has an edge. Yeah, product refinement area, and product refinement is in the area of trying to make it perform better, make it last longer, or make it cheaper. Right? And there are other categories, but let's pick these 3. In these 3 areas, I believe modeling and simulation plays a big role. But when you talk about the small, medium-sized companies, I think the difficulty of them, to draw them into using HPC for modeling and simulation in these 3 product refinement area, the difficulty is really in the fear of a HPC system, right? Do I have to learn Nastran? What is Nastran, right? Do I have to learn ANSYS? Do I have to learn Fluent? I think as we spend money in building HPC centers, we should also think about, when we get budget for HPC, to also spend money on consultants, right? Engineering consultants that would actually go out to these small, medium-sized companies and then draw their simulation products in to the centers for work. Yeah? That's should be part of the budget, yeah? To get small, medium-sized products to be simulated in the centers. Yeah? Not wait for them to come, but pull them in, right? And I think this is one way, if we focus, put budgets onto it, it's one way we can get the product refinement area for the US to go up. Yeah. Then after that, we move on to trying to mass produce it cheaper, right? Yeah. So conceptualization, I think we are good. We have to get the refinement up, and the way to do it is to pull them into the centers. And then next, we'll look at mass producing cheaply.
Sure.
Good.
let's see, what can I add to what all the good points that have already been made? But one thing I guess that I would continue to highlight would be the ease of use challenge for these smaller deployments. A lot of people do have it's a single workstation today and it's transitioning to a cluster, or you're going from a small cluster to a medium-sized cluster, and the expectations that they have to have something that's very easy to use, that's straightforward, that doesn't require a large IT staff, that is completely critical. The ISV topic that's been brought up a couple of times, even there, the transition for a lot of these codes to being multi-core aware and able to leverage clusters, that's still in the process of happening for a lot of the ISVs in this sort of marketplace. Certainly both ANSYS Fluent as well as Star CD have been modified to work under much better parallelism conditions. And so, for example, for those two ISVs, it is much more possible for people to migrate from the workstation level to the cluster level. Of course, for Panasas, one of the problems that we've specifically worked on is the data I/O challenge that happens once you start to have a larger size cluster, meaning maybe tens of nodes. So being able to have a single file system that's available, that's easy to manage, that's been what we've attacked, and we've worked with the ISVs to, for example, put in parallel I/O backends into their software, so that the software recognizes, oh, there's a parallel file system, let's take advantage of it. But I suspect each of us here on the panel has a role to play in making their own solution easier to manage and fit in for those types of users.
So, thank you all. I mean, there's so many different things that I noted. It's speaking a new language in terms of the benefits to the small user, speaking to them clearly and simply about the business outcomes. But other phrases, locality, being accessible and near to them. The centers mentioned a number of different ways. Draw the small manufacturer in. This idea of access and fear of concepts like parallelism, threadedness, the learning curve, sort of a fear to come in and get in. So in this country, we've solved a number of problems that may not seem as technical in the past in different ways. Agricultural extension is an example. Let me use that. I mean, any state, you can go to the Ag Extension office and you can say, I got a problem with my crop, help me out. And that's been going on for 100 years. There's the Service Corps of Retired Executives, which as a management consultant, they drive me crazy because they're free. But they're out there. It's older people to help people with their business models. We have the ability to go to other countries and help them with their water systems, with the Peace Corps, et cetera. What do we need to build, or what could we build as a system to bring the fearful, uncertain small manufacturer? I mean, they can buy hardware, but that's, I guess, no longer the main point. Close that gap, support them in their locality. I mean, it's nice that you can go to Oak Ridge and get some help. I think it's wonderful. But what about the idea of an Ag Extension office for HPC? Can we build that? What about the concept of helping them in their locality, and what do they need? Anybody want to start?
I'll start.
Dr. Feiereisen.
So some of what you were asking is behind some of the questions that I asked, starting out with John West yesterday morning. And, you know, with one of my other hats on, I'm part of this Alliance for High Performance Digital Manufacturing. And, you know, I was grateful earlier in the year to see that Addison gave us a reasonable report card. And he actually, you know, pointed out that we're one of the organizations trying to promote the use of computing in the manufacturing space. But the motivation for my question, both this morning and John yesterday, was that HPDM is an ad hoc organization of laboratories, government agencies, vendors, OEMs, et cetera. There is the National Center for Manufacturing Sciences, nonprofit organization, also a collection of vendors, OEMs, laboratory people. What you talked about has been discussed a lot in terms of there being an extension program, and there is actually a government entity called the Manufacturing, I think it's called the Manufacturing Extension Program. We just know it as MEP and always refer to it as that. And the question in my mind, one of the $64 million questions, is that assuming that we need organizations that show leadership in this area, put together consultants, curricula, hold the hands of small manufacturers, is that a proper function that should be done at the private industry level? Should it be done at the nonprofit level? Should it be done at the National Institute of Standards, Department of Commerce, Manufacturing Extension Program level? And I just don't know, because there are definite disadvantages and advantages to going in both directions, not the least of which is the time frames that commercial companies can actually spend on developing markets that are probably going to take 5 to 10 years to develop, and yet we're under restrictions to be able to show return on our investments 1, 2, 3 years. Government agencies can do these kinds of things on a longer period of time, but then what kind of staying power do they actually have in terms of personnel and budgets and such? And I would throw that out as being one of the $64 million questions that it would be useful for us to address collectively.
The answer to your question, what kind of staying power, is one election cycle. Beyond that, we don't know.
I think part of the issue with having the small companies is they don't, you mentioned the fact that it's a large outlay of not only capital but personal resource, whether it's the programmer, the administrator, they have the hardware, they need a facility to put the system into. And when you talk to some of these guys, they realize that they don't even really need the systems 100% of the time. A lot of times they're running their jobs and they're making small changes and rerunning it, not because they need a new answer, just because they want to show that they're using the system close to 100%, so the next time they want a bigger one or another one, that they won't say, well, you only used it 18% of the time, so why should I buy you a bigger one or a faster one, right? So, they being able to share systems, right, in a cloud type situation, right, and I hate to use that word because it's not anything that we do, or but a cloud or compute on demand or whatever we're calling it this week, grid, all of these different things to be able to share resources, whether it's people or hardware. But from a vendor perspective, the problem that we have is it's a lot of work for a very small amount of revenue, right? You almost need to bring in somebody who isn't looking at making a profit to either subsidize or run a program like that, right? So this seems to me to be a good place to bring in a government entity to help out with enticing somebody to do it, or creating some sort of a consortium to go out and do it, because if you have all of these people who want to use it but they only have a small amount of money, managing the people, managing their data, managing access, or managing lots of tiny little clusters all over the place is a lot for a vendor for a fairly small return.
Yeah, that's accurate. Oh, go ahead.
So I just want to throw out, China's been mentioned a few times. I think India could also be looked at as sort of an up-and-coming user. So I think India is sort of, I would say, had a lot of false starts in supercomputing, but they recently, of course, rolled out a new 5-year plan, which has been, widely talked about, the $1 billion plus of investment. Interestingly, that both India and China have these 5-year plans, so maybe we just need to change the election to one term, 5 years, or something. But certainly, it's interesting that the largest supercomputer in India will soon be the one at the India space program. So again, I think having that national level funding and key initiatives, key sort of anchor initiatives, albeit in the manufacturing space, are important, combined with that local outreach. I think there's nothing like accountability and transparency, right, for how resources are being used. And one of my best examples is, I guess it used to be called the TeraGrid user portal, but now the Exceed user portal. And you can go Google it and look it up. The TAC Ranger system, which is, I think, still 4 years later, is still the second largest resource. So that's a little bit embarrassing that, you know, a system built 4 years ago is the second largest NSF Exceed resource. But you can go up and look on the user portal. It's still consistently used, you know, above 95% of the time, versus there's other sort of more specialized systems on that portal that are not being used at all, or down, or being used 5 or 10%. So I think that transparency and visibility into, you know, how anything that we do, how those resources are being used is important.
Yeah, I couldn't agree more. In fact, the locality component of this is huge. Our business model for POD, which is our on-demand, HPC on-demand service, is a federation of resources sprinkled about the country. Now, it's a global resource, and we do have people running on it across the globe. But the idea, of course, that we're not shaking this federal, this locality component of this is important. I think that if you look at the way, getting closer to what Marc was saying, the way that the federal monies are spent, there are a couple of restrictions in terms of the color money that are challenging for commercial collaboration in the space. The idea that certain funds cannot be used as services, but have to be only used for hardware procurement, severely limit the ability for commercial entities to collaborate in sort of an on-demand fashion, which is, let's face it, that's what most of these supercomputing centers are. They're sort of on-demand facilities, if you will, when it comes to their outreach programs. So we think that's a big challenge, and we need to have a little bit of a change around that. I think us as a country thinking more about the utilitarian component of cluster computing or technical computing is critical. We still don't really look at it that way as we fund resources. I mentioned China. We're going to mention it again. But I mean, if you look at the way they fund things, 10% of the resource goes to software development, 30% in this country goes to software development, if you look at it on an annual basis. So the software is a huge piece of that as well. But I do think the best solutions come from industry. I think what we need is a kick in the pants from the federal government to sort of get things rolling in certain areas.
Anybody want to add?
I'll add one more point, which is, you know, another trend that we've certainly been aware of is increasing partnership between corporations and the secondary education system. So we've seen a lot of examples of genomics companies and even manufacturers sponsoring research in our university system, and so that research then ends up getting performed, those simulations and design work ends up getting performed on university supercomputing center resources. So that's another way besides cloud, which is of course also a great way of alleviating that initial upfront investment, but being able to basically sponsor that research and outsourcing it into the university system has been quite successful, especially, I would say, especially in genomics.
So we've had a lot of programs of various levels of accessibility and success, but the existing gap, which we've been talking about for years, is in skills, is in a programming model that requires a level of expertise which is, frankly, beyond the reach of a huge portion of the companies that we're talking about. So in closing that gap, we either need to provide them with the skills and the expertise and the help, or simplify the model tremendously so that they can make use of it. Let me ask this in a broad way: is there a business model for that, for the vendor community that works in terms of serving this community? Does it have to be provided by a nonprofit entity? Is there a model? What is the sort of the ideal shared responsibility and cooperation between the expertise that's resident in government, academia, and the vendor community to serve these people so that we can overcome the fear, make it local, help them port, help them achieve? Wide, big question. Ideas? What does the model look like? Can anybody make money?
So This is related to your previous question, and a couple of things are getting linked together. One of which was John West, one of his bullets where there was no social support for doing this. The other is we've noticed that India has a plan, China has a plan, Russia has a plan, and we've got a hodgepodge of things. I had the distinct benefit of touring the International Center for Auto Research in Greenville, South Carolina, where I live, and that's the home of BMW. And BMW, the sign outside says BMW Manufacturing, but if you ask them, it's really an assembly plant. And they don't manufacture anything. They have hundreds of small, medium manufacturers within 100 miles of them. Over 200 of them are foreign-owned, and there's 20-something languages they have to deal with, spoken languages. And the International Center for Automotive Research is there to help address the problem we're talking about in this local issue with hundreds of small, medium manufacturers supporting one final goal, and that's the assembly of a BMW. Their plan is to review the requests from the mothership, BMW, out to all the small manufacturers and see if there's some commonality where they can improve efficiencies. They've found that there's very little standards, if any. The lowest common denominator standard is blueprints and the numbers on them, because numbers are universal. The rest of it is a hodgepodge. So their plan is to assist these small, medium manufacturers to better compete for the business of BMW with their help and build up that social network that John was alluding to. And as a practice grows of sufficient size, to transition that to a 2-year technical college. And they have done so in 3 areas. So it's a successful model. It's kind of quiet because they make money doing it.
So that's a completely private model, except for the fact that the state has provided big tax breaks for them to arrive, right?
Well, they do that everywhere for large manufacturers, don't they? Or they wouldn't end up there.
Not in Massachusetts.
One other point, I don't think a bigger, badder supercomputer is going to help the small, medium manufacturers. And so I think our attentions are divided between the race for exascale for some reason and to be competitive worldwide in manufacturing.
So part of your question to begin with was whether we should somehow be able to produce more scientists who are literate in applications in the domain, in the numerics, and high-performance computing itself. And I think the partial answer to that is yes, of course. But I think that the corollary to that answer is that producing those kinds of people, I'll call them Renaissance scientists, because they know enough of a whole bunch of stuff to get all of this done. They are people who have sort of mastered the whole range of technologies and can get something done for you. But to educate a whole cadre of people like that is not a scalable solution. You know, if we're talking about manufacturers in this country alone, you go to the statistics of the National Association of Manufacturers, and they have 300,000 registered manufacturing businesses. Now, okay, it's going to be some small fraction of those people who can actually benefit from using modeling and simulation. But nonetheless, it's still going to be in the tens of thousands, and we're not going to be able to produce that cadre of Renaissance scientists who can go and service them. So I think part of the answer to your first question is that we have to be able to figure out how to, number one, compartmentalize the technologies such that we can teach a piece of them to people and they can be productive in their area, interacting with people who have mastered the other parts of the technologies. And so we have to think about what that actually means in our curricula. So many of these Renaissance scientists have come out of the big computer science departments, or out of mechanical engineering, or out of aeronautics and astronautics at the major universities. But should there then also be a parallel set of curricula that is more associate degree oriented, or computationalist oriented, or certificate oriented, that can produce that mass workforce that can actually turn the crank when these things are developed?
You can certainly get certified in diving, in welding, I don't mean to equate it to understanding simulation, but it's a targeted set of known outcomes that it doesn't require a degree program. I don't know if that works in this instance.
So I don't want to say that venture capitalists are always right, but if you look in other than maybe what Andy Bechtolsheim is investing personally, there's not a lot of venture capital that's gone into HPC in the last 5 or 10 years. But certainly anything in big data, right, is interesting, and I think that's certainly an opportunity, because ultimately you have to have, whether it's a high school or college graduate or commercial company, you have to have some monetary incentive there. And I was meeting with a very large consumer goods manufacturer, and they had an HPC system, but they didn't want to talk about that. They wanted to talk about Hadoop, right? And they didn't really know what Hadoop was. In fact, they didn't even know how to spell it, but they knew that they wanted Hadoop, right? Because of everything that they'd heard about big data. So maybe a way to sort of capture some of that manufacturing expertise is to restate it not as an HPC or a technical computing challenge, but as a big data challenge.
As a marketing guy, if you don't call it the right thing, you can't sell it. When's the last time you saw something labeled prunes? They're dried plums now, so you can have as many as you want.
But there is some convergence potentially happening there with Hadoop. And at Panasas, we actually use big data as a catch-all for not only the traditional HPC simulation workloads and classic research and design, but also some of the large web repositories of data, as well as the analytics space. But even in terms of Hadoop, the next versions of it to Hadoop, which will include Yarn, will start to have MPI scheduling in it, and there's a convergence there that can and maybe will happen, where it'll become a lot more relevant for HPC, using Hadoop as a framework. So that'll be a very interesting trend to watch over the next couple of years.
So on another track, so we have this locality issue, staying power, and scalability issue. Maybe one thing we can do is, since we have the supercomputing centers already located, granted that they are not very much geared towards small, medium-sized businesses and manufacturing companies. Perhaps we expand the NSF funding to include, to be one way is NSF plus DOC funding to all supercomputing centers that have now a new additional charter that has the requirement to go pull small manufacturing companies in to run their simulations on the supercomputing center. The NSF money buys the capital equipment, while the DOC money hires people, for example, right, to be at the centers. And these people, funded by the DOC money for the supercomputing center, their goal, 80% of their job is to pull small businesses in to run their simulation on the supercomputing. So perhaps some of these, it's not a perfect solution, but perhaps some of these issues that we are seeing, scalability, locality, could be fixed using this approach. Yeah. And I think the centers would like it because now they have an additional charter for outreach. They have always been wanting outreach capability, and now they get also a new source of funding for people, and this time from the DOC. But I guess this will require the NSF and the DOC to get together to say that this is going to be the new additional charter for the centers. Yeah.
The additional required element would be a vast expansion in the number and availability of mentors,
yes,
capable both interpersonally and yes, business-wise. It's a renaissance.
Correct.
People in a way.
And 80% of their jobs go out and pull people in. Yeah.
It strikes me that this may not be a model for it, but we've achieved this in different ways. And if you walk into a nuclear plant anywhere in the United States, place is just filled with guys who are in the Navy, on submarines, who didn't necessarily start at college, who acquired all these skills through a really rigorous, well, thank Admiral Rickover, right, from the beginning, rigorous training program which was set up and has yielded a pre-made set of highly trained technicians who may not be highly degreed, but they're there.
On-the-job training.
on-the-job underwater training. Yes. Additions?
But more investment in the highly degreed scientists is also completely key, right? And that's one of the things that has been very successfully done in China and elsewhere, is recognizing that if you sponsor a new PhD, build up a center of excellence around them, then you attract the talent that has an ongoing effect. And solving the tactical problem of having enough technicians and solving the locality problem, that's part of the picture. But so is the longer term view is, how we need to invest a lot more in long-term science and research here in the U.S. than we are today.
So there have been a couple of cases mentioned where HPC has helped. I don't mean to just dwell on the small manufacturer either. And let's talk about the missing top. I mean, even if you're talking about over 60% of major manufacturers having some form of what we would qualify as HPC, I have a wine cellar too, but I don't go down and get the Petrus every night. There isn't any Petrus, just between us. But a really good bottle of wine, are they really using HPC on an ongoing basis? So when we look at those large manufacturers and the small manufacturers as well, I'm wondering, we've heard a few cases, we know about the classic cases of making Pringles fly and making airplanes fly. I'm wondering if there are success stories or cases or models that you've personally been involved with or seen work that might be good case studies or reference examples for a great collaboration as we're talking about. Are they out there? Have you experienced them?
So the key word, I think, in what you just said is, are they out there? They exist. And, like I'll cite from the standpoint of my own company, Intel is one of the biggest manufacturers on earth. And much of what gets done in terms of the design, the verification, and the transmission into production is all HPC and modeling and simulation. And we eat up an awesome number of cycles in that whole thing. Some of it is actually solution of partial differential equations, in the standard modeling and simulation sense, but an awful lot of it is circuit design and verification of logic and such. But it is high-performance computing. Now, when I say out there, are we going to be able to show that in terms of case studies that are going to entice other people to come into the field? Well, we talk in general about it, but it's not going to be something that really is going to be of value to many companies in the sense that, oh, I see how that's done. I think I could do that kind of thing also. You could say the same sort of thing, I think, about more standard types of simulation in the oil and gas industry. We know that it's being done, but one of the things, I saw this again off of Addison's charts this morning. A lot of the software that's used in there is proprietary. It's internal. And you're not going to see the case studies that are actually going to come out about that kind of stuff.
Agreed. We're fortunate enough, even though we're a small company, we usually will get a fairly broad spectrum of participants in any given industry. One of the things that I noted personally over the past few years is in the heavy equipment manufacturing market, we deal with the top 5 in that space, and we deal with a sea of others underneath who are leveraging our HPC on-demand service. But specifically in this top set, there are 2 that I'll contrast. One has a $23 billion market cap, another has a $70 billion market cap. And not to infer that HPC has given them that, but as an example, it's a mindset thing in these larger companies. If you have a leadership who is of the mindset that design and simulation and modeling and simulation will change and transform their company and make them more progressive, it happens. And those who don't, it's an amazingly stark contrast. The one company who is a $70 billion market cap has 2 to 3 of the top 500. They're private, so they don't declare them as such, but 2 or 3 top 500 supercomputers running at all times, and most of them are running at 95+% capacity. They have the capability internally to almost design an entire machine, soup to nuts. Their second competitor in the space, who's a $23 billion market cap and trading actually a little bit higher, has nothing near that. In fact, most of what they do is still build the engine, run it till it explodes, see what failed, and start over. I kid you not. Now they have 90 silos dedicated to this that cost them $3 million each to run throughout the year. Can you imagine if you were to just shift that investment and put that into HPC, the savings that would represent for them as a company, number one, and number two, what it might do for their overall position in the global market space, not even talking about just the US. So it's really interesting when you sit back and, we as vendors have the ability to do this candidly and see the impact that HPC has on these companies.
I think a couple of good examples that I've run into was one place where I really didn't expect to see high-performance computing, which was Pampers. Right, so when somebody said, I'm from Johnson & Johnson, immediately, I started thinking about, well, there's a whole bunch of different things that you might be able to do with it. And he's like, I'm from the Pampers division. I'm sitting there trying to figure out, and then I realized, right, he's doing flow analysis and he was using LS-DYNA to try to figure out exactly what kind of patterns and all of those things. So that was, I thought, was a kind of an interesting place that I didn't expect to see it. Another good one was Renault with their Formula One team. So to be able to see the type of CFD analysis that they do and their ability to be able to make changes on the fly, and I learned a lot about Formula One from dealing with these guys and how few things they're actually allowed to change. There's very strict rules about weight and size and all of the different aspects, the tires, and so it really came down to two things that they saw. One was the driver, and the other one was airflow. So they would run simulations 24 hours a day, 7 days a week, so that and they would make changes to their cars in between races, which could be only a couple of weeks between the different races, and they would make changes to try to improve the aerodynamics of the car and create more force down, which seemed counterintuitive, but force it down and be able to direct the airflow. So it was really amazing to see how much they relied on CFD analysis instead of using wind tunnels now.
Actually, the Pringles example is very similar. They wanted the Pringles actually not to take off from the conveyor belt, but to hug the belt. Yeah, that's Procter & Gamble, right? So that's a big company. They can afford R&D labs. They can afford R&D engineers to think, about using new tools to solve their problem. But the next level down would be, say, a company like Speedo, which is smaller than Procter & Gamble. In fact, they changed, for the Beijing Olympics, they changed the entire game with regards to swimsuits to the extent that FIFA banned their swimsuits after the games. Yeah, it got so good. It was because one very bright engineer at Speedo decided to use Fluent to run simulation, and then had the foresight to actually go to NASA to use their wind tunnel. And they came up with these LZR swimsuit that cost about $500. And for patriotic reasons, Speedo decided not to sell it to any other country except for US swimmers for the Beijing Olympics. Yeah, yes. And then they started selling it for $500 a piece after the Beijing Olympics. So in fact, an interesting story for this one was that there were other swimsuit sponsored swimmers that actually went to their sponsors to say if they could wear Speedo for the Beijing Olympics. Yeah. And those were the swimmers that had their own sponsored cap logo, but Speedo swimsuit on them. So they were all US people, and they won their races. Now, the point here I'm trying to make is, as you get lower and lower down to smaller and smaller companies, you have less and less resources to set aside for R&D. How do we fix it? Well, at least we recognize the problem. We know the biggest companies like Procter & Gamble can do it for Pringles. Speedo, slightly smaller, can still do it. But how about the 10-person company? Yeah, so we first recognize the problem and we fix it. Find some bandwidth for these people to do R&D.
I've got one small one related to the original list of questions, and it somewhat relates to Stephen from Intelligent Light talking about the bicycle wheels. Trek builds downhill mountain bikes, and they had a problem with what they call conflicting design goals. They wanted a light frame. It had to be sturdy because it was headed downhill and need to look good. None of that has to do with time to market, blah, 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 that we always talk about, right? So we have to couch the answer in terms of the way the problem was positioned. They wanted to go from aluminum to carbon fiber. And typically this takes them 8 to 12 months. They were able to analyze in 4 months more designs than they typically could in 8 to 12 months. And the bottom line got down to something that was kind of shocking to me. The result of all the design effort is something they called a printout. And the printout, I don't know what it is, but they cost about $2,000 a piece. And then they hand it to their manufacturer, and he builds a prototype, quantity 1, which they evaluate. They usually do 4 to 8 prototypes, 4 to 8 printouts at $2,000 a piece. They were so convinced in the simulation results that they went with one. It went into production, so they saved $8,000 to $10,000, and to them that was significant. And they saved about $10,000 per prototype, which was another few $1,000s, which was significant. And the result is they won the World Cup downhill bicycle race in 2011 with this new design. So it's small amounts of dollars that are saved to meet their design goals if you approach them with an answer to the problem in their language.
The issue of communicating this to, to a large number of small to mid-sized manufacturers in terms they can understand, the question in any market is who benefits, who cares? Is the number big enough to motivate anybody? So it's kind of such a untargeted, unconstructed market slice that it's hard to figure out who's going to go after it. Dr. Goh, I think you mentioned that the swimsuit was tested in a NASA wind tunnel.
Yes.
I'm picturing this guy standing alone in a Speedo.
Speedo.
I'd be nervous, personally.
It's a model, right?
It's a model, okay.
A model of the person.
So, okay, we have all these challenges and some possible paths to get all these things, the locality, the expertise together. What, if you could take you find a magic wand or a magic, what do you call it, a vessel on the beach, and you could rub it and get the one outcome you could that would get us closest to all the things we're doing, what we want to do for small manufacturers. Would it be the mentors and the skill set? Would it be some breakthrough in maybe kitting up or putting a total ready-to-roll solution together for a certain limited number of CFD or other types of solution that would be, the interface would be understandable, would be accessible, we wouldn't have to have the development expertise. What would be the small set of things that we could look forward a few years to try to involve these people best in terms of technology or kitting or prepping technology that would help them out? Any ideas on sort of a vision of how to roll this up for them? While we wait.
Okay.
Let me just say that I'm going to go to questions in a few minutes, so prepare your questions.
So would I get 3 wishes out of the lantern?
You may have as many as you
So
like.
I'm really pleased with Stephen at Industrial Light and his licensing model of no licensing on the back end. So that the machinist or the SMM practitioner is working at his desk is totally ignorant of what is out there at the other end of the wire, its size, its cost, et cetera. He can do his job. So global adoption of the batch processing licensing model would be number 1. Number 2 would be focused appliances at the site of the small manufacturer. And then thirdly would be local ICAR or community college type consortiums to provide that social support that's needed.
Pretty good wish list. Hope you get it.
So I'll add 4, 5, and 6 on there. And I think part of what needs to be done is to have more believable case studies that can actually show a business something similar to what they could do themselves. And those case studies are more than just, here's what we did, you know, we used this code, blah, blah, blah. But they also address part of the business model. And I think there are 2 things in the business model that we have no case studies or data to show anybody on right now, one of which is actual return on investment. For a company having adopted HPC and it improved their business, and show how that actually was done. And I think the other thing that we have no data on, but we need to be believable in our argument, is to be able to show how introduction of computing technology actually reduces risk for a company. And so if I was going to rub the magic lantern, I would ask for more case studies that actually had data in them rather than just anecdotal stories.
It's your chance. Magic wand.
ROI examples are great, but it reminds me, it's sort of like PUE, right? Everyone measures it differently, so you have to be a little bit specific, I think, on the ROI. But you know, I think if I were to put my money in one spot, it would be in the university education and in the mentorship, and figure out some way to, you know, tie that through scholarships. Again, you know, that's one of the big challenges today is, you know, someone graduating high school being able to afford college and go through and do some very targeted funding there.
Yeah, I would agree with Mark. I think it's a challenge to really, let's put it this way, it's a broad market. You pointed out earlier, Bob. It's a very broad market. It's very difficult to tackle it. I think you have to think about this in terms of aggregation points. I think we need a shot in the arm in terms of the way that we fund this sort of thing. We need to free up the funding for collaboration. I think we have to think about this as, you know, the way we look at things on our side when we launch a new product as a small company. We think there's a spectrum of product to project, right? And as the tools become more evolved, you move more toward the product side of things, and we're not there yet. But I think if you try to solve that problem and you try to solve the expertise problem together, by aggregating those into singular facilities or single sort of domains and having people work on these problems as a community together, you start to come across with brighter solutions. There are a couple of tools, a couple of examples. I mean, I think everybody's aware of the work that's being done under the Blue Collar program. That's really interesting. I will look at the Hub Zero project from Purdue, where they're starting to create concepts of communities around certain problems within specific domains, creating the platforms to do that. This is no domain expertise within each of these disciplines. It's just creating the means and the platforms to do this. So the social aspect of this, I think has been hit on several times today, is critical. So I think as we start to evolve how we attack these problems, we just have to think about them differently, and we're not doing that as well as we could today.
So when we talk about universities and being able to get the resources, the human resources, that kind of hits near and dear for me, right? I mean, this is one of the things that I discussed in my after-lunch discussion yesterday, which is a lot of times it's about the people, right? It's about the people who are going to execute. You can go and you can get hardware and you can create facilities, but having people who are going to develop the tools, who are going to develop the programs, who are going to understand how to utilize those programs is becoming more and more of a problem, I think. Just going out and hiring really smart people who have background to be able to take advantage of HPC is becoming more an issue because our young talent that are going to college are being diverted into things that are maybe a little less productive but a lot more interesting. So Last year I mentioned I have now a 17-year-old son who is going to go to college and he's going to be a computer programmer. So I asked him 2 years ago, what do you want to do? And he says, I'm going to program games. I'm like, oh, good. That's just what we need is more game programmers. Now, in the last year, we've done a little bit of travel, and I've taken him to, I took him to the Arctic, Arsk up in Alaska, and showed him some of the stuff that was going on up there. And we stopped in to see one of my other customers who's actually in manufacturing, and he got to see some of the stuff there. And we went to the Princeton Plasma Physics Lab and saw some of the stuff that they were doing there. And now he wants to do physics programming, which I think is going to be a lot more productive. So how do you get to these students and make them interested in doing things that will be better for the country, for the manufacturing, for jobs, for things other than playing video games and doing Angry Birds?
Yeah, I don't know how it happened. So I may have mentioned I become involved with some robotics startups and really enjoying it. And I never realized, because I don't have kids, robotics is a sport in this country in the schools. And almost anybody, I mentioned that to somebody here, and they said, oh yeah, my son's team just won their state competition for robotics, and it's a big deal. I don't know how that happened, because there's code involved. Well, a little bit. Mostly Legos, I think.
I guess that's disguising interesting scientific achievements in game form, and then you have them done right away.
Well, you can almost play to what is important to them. I mean, if you talk to different teenagers, you can get into, well, what's important to you? Well, the environment is important to me. Well, wouldn't it be better, rather than programming for Nintendo or whichever one you might want to pick, to go off and work on the next alternative energy, right, to help save the planet? And you start getting them thinking at least about things that are personally important to them, rather than maybe what's really cool, and you get them to a point where, so then you can go play those games after you're done work.
I was given a chemistry kit, when I was 12, and I broke my dad's heart by exchanging it for a record player. Here I stand. What can I say?
Didn't become a musician after that, no?
No, I didn't.
Yeah. I think the National Science Foundation also discussed this, right? How to get students more interested in science and the outcome of science. Yeah. But in the short term, what can we do, right, to try and get the small manufacturing to be more productive? Well, let's look at what's already set up. Right, on the private side, there is Amazon, EC2 and S3. And then on the supercomputing side, there are these centers. So maybe the DOC could do something, right? If it is a DOC charter to improve the competitiveness of small businesses, I'm not sure if it is. Why don't just try and work with Amazon, right? Figure a way to draw these small businesses to use the EC2. In conjunction with the supercomputing centers. So perhaps it could be a two-phase thing. The supercomputing centers funded by DOC pull the small businesses in. Once they get familiar with using the system, get them onto the Amazon EC2 when they go back to their own companies. Yeah. So perhaps there's something we could do with existing infrastructure without having to start new ones.
Perhaps develop a game called Angry CFD for the iPhone.
Actually, since EC2 has come up, there is now another industry of firms who have layered their own software on top of EC2, and then they're effectively selling software as a service, and in some cases even selling consulting as a service based upon the EC2 services. Another business model.
Not just on EC2, I could point out. But that results as a service, actually.
Let me rephrase all of this, Penguin on Demand. Okay?
Okay. Jeff, I kind of left you out there.
That's okay. That's the disadvantage of being last on the panel. Everything's
well, I could have gone the other way too. Let me open it up to questions. Just let me know. I'll come to you. Okay.
So, I'm listening to this panel, and it's kind of interesting to me because I'm looking around this room, and I'm sorry to say this, but look around at us, okay? The youngest person in this room, I don't know, 40, 35, maybe you? 90% men, okay? And you're asking yourselves, and we're preaching to the converted, and we're all sort of self-congratulatory that we see the insights, and we have no context about the broader IT market. Okay, the world is behaving differently around us, okay? And the HPC community has missed the ball generation. I've been in this industry for almost 30 years. Generation after generation. And we keep asking ourselves, why doesn't anyone want to be an HPC? Why isn't it sexy? Look around, guys. Literally, guys. I mean, I find it fascinating. Go to it, get out, step out, and go to an industry-wide conference. Go listen to the broader trends. Go listen to the fact that the third platform of computing is emerging, which is driven around content and community and services. Where are we? Okay? You want to build communities and services. You want people to build applications, do crowdsourcing apps around technical computing apps to draw in this new missing middle or whatever we define it as. We got to get with the way people are thinking about business. We're out of touch. We will remain out of touch. You know, we keep going back and trying to solve the problem from an HPC viewpoint. You know, build the hardware, they're going to come. They're going to see the light. It ain't going to happen. I'm telling you, if we don't mentally change the fundamental way we view the market, view users, user problems, the way society is flattening in terms of business constructs, market models, we are going to miss this. I'm telling you. Okay? It's not, this is, seriously, step out of the box. I have to share this for a moment because this is fascinating. IDC had their industry conference last week, 2 weeks ago, Directions, and I went with a colleague of mine. And my boss sends me a note. This is the truth. He says, why is it so important that 2 of you are spending a day? It's like, because you got to get out of the box. Step out of the box. The whole world is evolving around us. So the point I'm making is maybe we should begin to step outside of the metaphors that we keep trying to drive into the, drive this, the square peg into the round hole, and start reaching out to our peers in broader industries. What's going on in social platforms? How are people aggregating ideas? How are these new constructs emerging? And look at maybe there's new models to apply into this universe of trying to transform industries around new models. So it's not a question, it's more of a comment.
I just want to give a chance for responses, but extremely well taken, and I've heard about one of the Google founders, whose name escapes me. He's German. No, he's a professor, but he's putting together a completely free online university and trying to get it accredited. I mean, it's too expensive. It's a way to form, and the communities that are spontaneously forming around it, bringing people in, are enormous overnight. Exactly. And the notion of taking this expertise, which is so thinly spread, and building communities out of it is a point extremely well taken. I'll go to other questions. Yes.
Yeah,
please.
sure. I couldn't agree more with your statement. And in fact, one of the things that we've done in our organization at Penguin is aggressively, because we're an HPC company, that's what we've been doing for the past 12 years of our life, we've aggressively sought to diversify ourselves into the scale-out computing market to make sure that we are keeping track of those trends. And it has literally transformed our company overnight. I mean, it has been impressive the way that we've interacted and carried expertise from one market to the other, mind you. So there is a lot of transferability between what we're doing here and what's happening in the scale-out space. I'll give just one quick example. Life Technologies is a company that we do a great deal of work with, and we recently built out for them a Grand Challenge platform. And it is a fully automated HPC environment that, quite frankly, the users don't even know is an HPC environment in most cases. And they fire off their jobs to this thing, they pass a credit card, and if they get the results right, then they're going to win $1 million. And it's that sort of thing that really sort of transforms the market, and we have to remind ourselves constantly that's out there, and we need to think differently.
Maybe there is no such thing as locality anymore. Maybe everywhere is local. Ready for the next question? Anybody have another comment on that?
So I like what you said, Matt. And my question is this, well, first a statement. What I've heard here over and over again is, how do we get more people to do HPC? Maybe we're doing exactly what we need to do. And that is one of the arguments I have made is that by doing HPC, being an advanced technology, I'm a physicist by trade, and I don't think I'd want to build a profitable market out of that. But anyway, recruiters told me that too. But maybe we're doing exactly what we need to. And we need to recognize that if we attract the right talent, it's not going to be everybody, it's going to be a few people. We create the thought leaders that 3 to 5 years from now, when the technology becomes mainstream, that's what they're doing. And we're always going to be a small community. We're always going to be fighting for funding. But this is what we do. And in order to make money, we got to do exactly what you're doing, Matt. We have to take it, diversify into other markets. And as it comes down, we leverage that to be the leaders. So I'd like some comments and thoughts on that. Are we barking up the wrong tree?
I don't think so. And as a matter of fact, I think that was my opening statement in this meeting today. I really do believe that we're doing most of the right things here in this country. And we've just taken a different approach than the rest of the world. The rest of the world, you know, the comment's been made, they're building out their HPC infrastructures to catch up with us. We still have the lead. I think that how do we sustain that is the real challenge. So no, I think we're thinking about things the right way, but I think we need to think about things also differently if we want to grow. And I think these sorts of environments where we expand those horizons are critical to that.
Let me clarify. I think from the point of view of what we're saying in here, we have to broaden the environment. From what we're saying in here, we have to broaden the environment. We have to get more manufacturing. How many times can you redesign a potato chip so it doesn't fly off the thing? That's been done. I mean, there are applications out there. Maybe we don't want to bring the whole world in. We just want to let this technology flow down and be the leaders.
Yeah, and I think it's that transfer of knowledge that's not happening. I think one of the panelists here pointed that out today. A lot of it's done in silos, and I think until there's either a clear monetary driver on the other side of this to force us all to scramble for it, or some federal intervention to help that happen with aggregation of expertise and sharing that, and it's going to be a challenge.
I think potentially there's an HPC thought leader or rock star, or a number of them, who knows, maybe here today, who will eventually, or a group of people who will eventually be able to use the modern creation of communities to get some of these concepts across. And it's funny, it's an odd thing to say, but you know, if thought leadership in physics and parallelism and the application of CFD or whatever it is going to be going to get people excited, I think that's the way it happens today. Other questions?
This isn't really a question. I wanted to point out an event that happens at Supercomputing called the Student Cluster Competition. This is an event that's been going on for 5 years. 2 basic rules. 6 undergraduates, nobody gets a degree. 30 amps of power. Here's the applications you have to run. You've got 40 hours. Go out, meet a vendor, talk them out of hardware, architect a system, show up at SC with a screwdriver, put it all together. Don't sleep for 40 hours running these applications. I show up at this event every year to recruit, because any kid that makes it through that knothole doing all of those things has a brain and knows what they're doing. In year 2 of this, so I put this on in, what was it, 07? In 08, I did a bicycle theme. And I called up Trek Bicycles saying, I want some CFD data from bicycle. Their response was, how do we get access to this talent pool? These kids you're going to take to Austin are going to be great. We'd love to use HPC in our design, but we don't think we can handle using that technology. I think it exists, and I wanted to point out this event because I think all of us should be recruiting there. And I think it's more to spur on young people coming in and doing this HPC stuff.
Panel want to add to that comment?
Here. No, seriously. Yeah, we know of the event. I think it's wonderful. We support it. I think it's also an example of alternative ways of teaching young people what this all means. We're great supporters of alternative ways of reaching people, whether it be through alternative education, projects like this, social media, et cetera. So all of your points are well taken.
I went to an event at MIT called Battle Code, which they do once every year, and it is a gaming competition for undergrads. But the point of it is that the Battle Code game is based on learning. It's based on all the characters in the game learning from the last challenge, the last outcome. So it's a terrific recruiting event, and these kids, these students, most of them know they're not going to wind up writing games. It's just the vehicle, and it turns out to be a terrific recruiting venue for that purpose. So maybe there are more opportunities to do that with parallelism.
Thanks. So I actually want to comment back to something that Mike said earlier, but in the broader discussion about whether or not the market is, or that it's okay to have a small isolated group of people and the technology flows down. So I'm kind of more spanning around the bigger picture, right? So how do we make sure that as a country, right, that we are competitive, not just in sort of the classical way we think of science, but in terms of multidisciplinary thinking, right? So there's this trend in education called problem-based learning. Not all schools have embraced it. I don't know if any of you are familiar with it, but they bring kids together, and a lot of the leading-edge STEM schools are down this path. But it's all around real-world problem-solving in teamed approaches. So you're looking at multidisciplinary concepts, and they're trying to infuse new ways to analyze information and problem-solve. And I think, again, back, if we think about science and technology, the whole STEM field, and how do you weave that into social science thinking and everything, it's about insights, okay? How do you use computing? How do you use advanced methodologies to reach new kinds of conclusions with this multidisciplinary kind of approach? So I think, again, if we step outside of should it be the way it is, well, it depends on what you want your outcomes to be. Do you want an educated public? Do you want your kids to be able to compete long-term in a complex economy? Do you want them to have skill sets so they can problem solve across all these emerging domains? I would say yes. So maybe we should step outside of the way we think about science in these isolated disciplines and think cross-sectional. How do we use technology as a resource? Again, monikers of HPC aside, how do we use advanced methodologies and technologies to give ourselves the critical thinking and analytic skills so we can compete in the 21st and 22nd century? I mean, it's a mind change about how we educate our kids using the best technologies and tools we have out there. You wouldn't go and take a rock and hammer it now, for a nail. You'd take a hammer, right? People use hammers now. They don't just use rocks or other kinds of, when you do it, you don't have a hammer. But the point I'm making is that we should be thinking about HPC as a resource, something else in our tool chest, about using it as a way to create new kind of educational models that are cross-discipline. So I would push back on that point and say that the way we're educating our kids today and long-term should be about what's the best assets we can deliver so they have the critical thinking skills going forward. That's
maybe the shortest path to a new program, a new development model, getting away from the rigors of MPI is for people who think in terms of parallel problem solving from the time they're 8. Maybe they'll come up with it, because we can't seem to get away from it. Comments on before I go to the next question? Responses? You guys okay? I'll be right back.
I'm going to take this theme and actually try to phrase it as a question. Maybe do this. I mean, as horrible as old white men are, I nevertheless aspire to be one day. Personally, I think there's a competitive advantage in being the company that can attract youth or women or minorities into this space. So the way to phrase the question is, we've got some giants of HPC up here organizationally, as well as all the startups. Organizationally, what are you doing to attract more youth, particularly women and minorities, to your organizations? And what else do you think you could be doing?
Who wants to jump in first? Anybody have an offering?
So many, oh, go ahead.
Go ahead.
Many at SGI over the years, as we, over the years have left to join Apple, Google, and Facebook. These are the hot companies now. Many youths join these companies because they are the in thing, they work on mobile, internet, social networking. And that's how we got to understand a bit more about these companies and why the youth joined them. And one of the things we realize is that the HPC story is not getting out. Yeah. The results of HPC is not getting out. The Speedo story, the Pringle story, and the Boeing 787 story is not getting out. And that's part of and to answer your question, what we have decided as a corporate direction is that, for example, I can speak for myself. I give about 100 talks each year. Now I'm allocating a portion of it to be sure I give these talks at universities that is open to students. And a lot of times I'm really surprised after you talk about NASA's work on trying to land a rover on Mars and the simulation involved with that, all the way to the Speedo example or the McLaren Formula One example. You look at these young students who originally were thinking hotly about trying to join Facebook, right? Asking, not they have decided to join us, but asking interesting questions about what does this career mean to them. So I think part of the answer is to get our story out, and we have decided that to help with that, to go out and do outreach, give talks, not just to try and sell systems, but give talks to try and attract students.
It's 3:31, and our fun is over. Thank you very much. I want to welcome, thank the panel, please. Thank you all very much.